The rhythm of the seasons is a timeless dance that has shaped life on Earth for millions of years. From the cold, crisp days of winter to the blooming warmth of spring, the sweltering heat of summer, and the vibrant colors of autumn, each season brings its own unique changes to the natural world. But what causes these changes? Why do the seasons shift, and how do they affect life on Earth? The science of seasons is a fascinating story that weaves together the movements of our planet, the tilt of its axis, and the way sunlight interacts with the atmosphere, oceans, and land. To understand the seasons, we must first travel back to the very essence of Earth's place in the solar system. Our planet orbits the Sun, making one complete revolution every 365.25 days. This journey, along with the tilt of the Earth's axis, is the key to the changing seasons. The Earth doesn't sit perfectly upright in space. Instead, its axis is tilted at an angle of about 23.5 degrees. This tilt may seem like a small detail, but it has enormous implications for life on Earth. As the Earth orbits the Sun, the tilt causes different parts of the planet to receive varying amounts of sunlight throughout the year. When one hemisphere is tilted toward the Sun, it experiences summer, with longer days and more direct sunlight. Meanwhile, the other hemisphere, tilted away from the Sun, experiences winter, with shorter days and less direct sunlight. This is why the seasons are opposite in the northern and southern hemispheres. When it's winter in North America and Europe, it's summer in Australia and South America. But let's dive deeper into the mechanics. Imagine a globe spinning in front of you. As it rotates around the Sun, the tilt means that at one point in the year, the northern hemisphere leans toward the Sun. This is around late June, when the summer solstice occurs in the northern hemisphere. The summer solstice marks the longest day of the year, the day when the Sun appears at its highest point in the sky. On this day, sunlight hits the northern hemisphere more directly, warming the land and oceans more intensely than at any other time of the year. In contrast, 6 months later, around December 21st, the northern hemisphere leans away from the Sun, marking the winter solstice. This is the shortest day of the year, with the Sun appearing at its lowest point in the sky. The sunlight is weaker, hitting the Earth at a slant, and the days are much shorter. This lack of direct sunlight causes temperatures to drop, leading to the cold and often harsh conditions associated with winter. Between these extremes lie the transition seasons of spring and autumn. In spring, as the Earth continues its orbit, the northern hemisphere slowly starts to tilt back toward the Sun. The days grow longer, the Sun climbs higher in the sky, and the air begins to warm. This gradual change sparks a transformation in nature. Trees that have stood bare through the winter months burst into bloom, flowers push through the soil, and animals that hibernated through the cold months begin to stir. Spring is a time of renewal, a season of growth and life. Autumn, on the other hand, is a time of winding down. As the Earth continues its journey around the Sun, the northern hemisphere starts to tilt away once again. The days grow shorter, the sunlight less intense, and the temperatures begin to cool. In many parts of the world, the leaves on trees change color, creating a spectacular display of reds, oranges, and yellows. This is more than just a visual treat, it's a sign that trees are preparing for the winter ahead, shedding their leaves to conserve energy during the cold months. But why does the tilt of the Earth have such a profound effect on our planet? The answer lies in the way sunlight interacts with the Earth's surface. When the Sun is high in the sky, its rays strike the Earth more directly. This direct sunlight is concentrated, delivering more energy and warmth to the surface. When the Sun is lower in the sky, as it is during winter, the sunlight spreads out over a larger area, diluting its intensity and providing less warmth. This difference in the angle of sunlight is why summer days feel hot and winter days feel cold. The tilt of the Earth's axis also affects the length of our days. During summer, when the northern hemisphere is tilted toward the sun takes a longer path across the sky, resulting in longer days. In winter, the sun takes a shorter path, leading to shorter days and longer nights. This variation in day length is most noticeable the farther you are from the equator. In places like Scandinavia and Alaska, the summer sun barely sets, creating the phenomenon known as the midnight sun. In winter, these regions experience long periods of darkness, known as the polar night. While the tilt of the Earth and its orbit around the sun explain the basic mechanics of the seasons, there are other factors at play that influence how the seasons are experienced in different parts of the world. One major factor is geography. The oceans, mountains, and the proximity of land to large bodies of water all play a role in shaping local climates and the intensity of the seasons. Take, for example, coastal regions. These areas tend to have milder winters and cooler summers compared to inland areas. This is because water has a high heat capacity, meaning it can absorb and store large amounts of heat without changing temperature quickly. During the summer, the oceans absorb heat from the sun, helping to moderate the temperature on nearby land. In winter, the stored heat is slowly released, preventing coastal areas from getting as cold as inland regions. In contrast, areas far from the moderating influence of the ocean, such as deserts and high mountain ranges, often experience more extreme seasonal changes. Deserts, for example, can be scorching hot during the day in summer but drop to freezing temperatures at night. Similarly, mountainous regions can see heavy snowfall in winter, while experiencing warm, sunny days in summer. The position of a place relative to the equator also plays a significant role in determining the characteristics of its seasons. Near the equator, where sunlight is consistent throughout the year, there is little variation in temperature and day length. As a result, tropical regions don't experience the four distinct seasons seen in temperate zones. Instead, they typically have a wet season and a dry season, which are dictated more by changes in atmospheric circulation patterns than by the tilt of the Earth's axis. For the people living in temperate regions, the change of seasons has long shaped cultures, traditions, and daily life. Ancient civilizations, such as the Egyptians, Greeks, and Romans, closely observed the movements of the sun and stars to track the changing seasons. Many festivals and rituals were tied to the equinoxes and solstices, celebrating the arrival of spring or the harvest of autumn. Even today, modern societies mark the changing seasons with holidays and traditions, from spring festivals to autumn harvests and winter celebrations. Animals, too, have evolved to adapt to the rhythm of the seasons. In spring and summer, many species reproduce, taking advantage of the abundance of food and warmth. Birds migrate to warmer regions during the winter, following the sun's path to find better feeding grounds. Some animals, like bears, hibernate during the colder months, conserving energy until food becomes plentiful again. Plants also respond to the changing seasons, with many going dormant in winter to survive the cold and sprouting anew in spring when conditions are more favorable. As the Earth's climate changes due to human activity, the patterns of the seasons are shifting. Winters are becoming milder, summers hotter, and the timing of seasonal events, such as blooming flowers and migrating birds, is changing. Scientists are studying these changes closely, as they could have far-reaching consequences for ecosystems and human societies alike. In addition to the Earth's natural seasonal cycle, there are occasional variations caused by phenomena such as El Niño and La Niña. These events, which occur every few years, are the result of complex interactions between the ocean and the atmosphere. El Niño brings warmer than usual ocean temperatures to the Pacific, disrupting weather patterns and affecting rainfall and temperatures across the globe. La Niña, on the other hand, brings cooler ocean temperatures, often leading to more intense winters and increased hurricane activity. These cycles further demonstrate the interconnectedness of Earth's systems and how changes in one part of the world can ripple across the entire planet. Understanding the science of seasons also helps us appreciate the delicate balance that exists between the Earth, the Sun, and the life that depends on this relationship. Seasons are not just a backdrop to our lives, they shape the rhythms of nature, influencing everything from the blooming of flowers to the migrations of animals, and even the timing of human activities like farming and holidays. The tilt of the Earth's axis, its orbit around the Sun, and the interplay of sunlight with the atmosphere and oceans all come together to create the dynamic and ever-changing environment we call home. As we look out our windows and watch the world change with the seasons, it's worth remembering the intricate science behind these familiar patterns. Each season brings its own beauty and challenges, its own rhythms and cycles, all part of the larger story of life on Earth. Whether we're basking in the warmth of a summer day or watching the first snowflakes fall in winter, the science of seasons reminds us of the incredible complexity and wonder of the natural world that surrounds us.